So how to remember formula from the Fourier series means in the given problem, if f of x is defined in the interval 0, 2 pi, and if they ask, definitely they ask find Fourier series. If they ask Fourier series to the function f of x defined in the interval 0, 2 pi, we have to note down like this: Fourier series expansion to the function f of x is by 2 plus sigma n equal to 1 to infinity an cos nx plus bn sin nx. Here a0, an and bn are Fourier coefficients. To find those formulas are a0 equal to 1 by pi, integral limits are from 0 to 2 pi since the function defined in the interval 0, 2 pi. F of x dx, an equal to 1 by pi, integral 0 to 2 pi f of x cos nx dx. Bn equal to 1 by pi, integral 0 to 2 pi f of x cos nx dx. If the interval is 0, 2 pi, we have to find out three Fourier coefficients a0, an and bn, and this is a Fourier series expansion to the function f of x. Now if the function f of x is defined in the interval minus pi, pi, if you observe in the problem the interval minus pi, pi, you have chance to check whether the given function is even or odd. If the given function is even, you will get the Fourier series expansion as f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. If the function is even, if you try to find out the bn, automatically you will get it as a 0. If the function is odd, in that situation you got the Fourier series expansion as f of x equal to sigma n equal to 1 to infinity bn sin nx. Here to find bn Fourier coefficient, the formula is bn equal to the formula is bn equal to 1 by pi, integral minus pi to pi f of x sin nx dx. If the function is odd, here f of x is odd means sin odd, this is also odd, both are odd functions, that is the product is even. If the function under the integral is even, minus pi to pi can be written as 2 into 0 to pi also. F of x sin nx dx. Now if the function is even, we have Fourier series expansion is a0 by 2 plus sigma an cos nx. Here to find a0 formula is 1 by pi, integral minus pi to pi f of x dx. Since f of x is even here, you may write down this as 2 by pi, integral 0 to pi f of x dx. Now to find an formula is like this one, you will get 2 by pi, integral 0 to pi f of x cos nx dx. This possible with the interval is minus pi, pi. So to find Fourier series to the function f of x, if you are able to know this is even or odd, then only you will get like this. Sometimes the interval is minus pi, pi, but can't say whether it is even or odd. In that situation, you have to determine a0, an and bn, three Fourier coefficient. If you are able to categorize the given function as even or odd, then only you will get this. And the next one is half-range Fourier series. Half-range Fourier series means half range Fourier series means clearly the intervals in the previous session 0, 2 pi minus pi, pi. The range of these intervals are 2 pi. Now the interval is 0, pi. Its range is only pi. Clearly half of the range of these intervals. So that's why we are calling it as half range Fourier series. So two types, half range Fourier cosine series, half range Fourier sine series. Half range Fourier cosine series given by f of x equal to a0 by 2 plus sigma n equal to 1 to infinity an cos nx. Half range Fourier sine series f of x equal to sigma bn sin nx. Here to find a0 formula 2 by pi. Here the interval is 0, pi. So 0, pi f of x dx. To find an 2 by pi integral 0 to pi f of x cos nx dx. Here to find bn formula 2 by pi integral 0 to pi f of x sin nx dx. Clearly, if you observe, half range Fourier cosine series coincides with Fourier series of an even function defined in the interval minus pi, pi. This half range Fourier cosine series coincides with Fourier series of an even function defined in the interval minus pi, pi. And this half range Fourier sine series coincides with the Fourier series of odd function defined in the interval minus pi, pi. This completes the formulas.